Okay, for the online students, so most of you are in quarantine, right? Yeah, few of you still hasn't come, but most of you are still now in quarantine in Taiwan, right? Okay. How do you feel in the quarantine? Okay. Yeah. Bored. Of course, you will be bored. Yeah, just please wait for another days, and you can go outside and have a sightseeing for around Taipei, and probably like some tour in our university. Yeah. Okay. Okay. Anyone of have you scanned all of you scanned? Okay. Okay. I think we can start our class. Uh, okay. First, I will start with the some GeoGebra stuff. Okay. So has any one of you tried um, to dig in the GeoGebra? Okay, so GeoGebra. Okay, uh, let me just write some functions first. Okay, I have some functions here. Okay, let's just start with the x squared. Okay. This is just reviewing some basic stuff from quadratic functions. Okay, so if you see here, uh, because we start with the x squared, you will see we have this is called the minimum value. Okay? If you remember, I'm just reviewing, and our minimum value is when the x is equal 0, right? When x equals 0, and then in this case, because it's only in the 0 position, the f of x is also 0, right? For the minimum value. So x and y in 0, 0, right? And when I move my graph, okay, to here by minusing the functions, okay, x squared minus 2. Okay, so your functions goes down 2 points, right? But your x value for the minimum value is still in 0, right? X is still 0. But when you plug in that x, it's negative 2, right? This y. Okay? This is the minimum value, 0 and negative 2. Okay? And then the third function, you have uh, x minus 2. You move the x squared. It's the same shape, and you move to right side 2 points, right? And what happened with the minimum value for the x? It will be 2, which means it's actually your solution when you are equaling this x minus 2 to 0, right? It's the solution. So x is equal to. But the function value is 0, right? 2 and 0. You will see here when you plug in 2, it's 0, right? So it's just a confirmation. I just want to remind you that you can confirm through the graph. And to prove that this standard form can help you to find the minimum and maximum value. The fourth one, you are having moving to the right side 2 points and then downwards 2 points, right? So you have x minus 2 squared minus 2. Okay. You can say that your minimum value, the point is, you can see here, it's 2, right? From here, this is, I call this h before. So h is 2, okay, here 2, and negative 2. But this part is the same as the equation, it's negative 2. So it should be multiplied by negative to be 2 and negative 2. So you can use this form to determine the minimum and maximum value. Or if you want, we can go back to the ABC, ax squared plus bx and plus c. And you will see that from there, if you expand this form, the standard form, if you expand, becoming x squared plus x plus c, the minimum value is negative b over 2a, right? So you can have several ways to find the minimum value. So from negative b over 2a, you can plug in that negative b over 2a to the functions, and you will get the f of x, this value, the negative 2. Okay. Or you just simply rewrite all the equation to the standard form. Okay. But if it is having irrational numbers, then you need to use the quadratic formula. Okay. Okay. I think we can move to okay. This is last discussion. Today I want to give you some snacks, but I forgot to bring it. But maybe next Tuesday, because tomorrow is the holiday, right? Mid Autumn or Moon Festival. Okay. Let's just start with some intro for uh, local max and local mean. Okay, just for your notes here. So if you have A, B, this is f of A, this is f of B. Okay. This point and this point is B, the f of B. Okay. This is f of x, of course. So we call the point a f of a here is the local max. And this point here is local minimum. Okay. So imagine the function is not just in this interval. So it will be like going here, and the function is going there. So it's like really long functions. So you call local if you are setting into some intervals. You call them local. But you may call them absolute minimum or maximum if that point is really the absolute minimum or maximum from the whole function. But because we are restricted this function to be only in the AB here, we only see here this point, then this is the local max and this is local minimum. So if the polynomial, if Px, I just write the general equation of Px if this general equation is polynomial degree n, then Px has at most n negative 1, or I will write with the different color. You may also call the minimum and maximum with the terms extrema. Okay? So the polynomial, in the polynomial situations, okay, when you have some degree n, at least, okay, at most, the maximum and minimum, or the extrema, will be n minus 1. So if you have like squared, there's only 1. Like x squared is only 1, right? If you have cube, you have 2, 4, and etc. Okay. So the next section will be the dividing polynomials. But before I'm going to explain to you the dividing polynomials, may have some examples. Okay. From quadratic functions, inequality. Let me just move to here. Just start with these two first. Okay. So the first one, the question is find the solution for all the inequality. Find solution for the inequality. So these two, how much time do you need to solve this? Do you think you can? If you finish, raise your hand. Okay. Also, for the online students, if you try to solve, you can write the answer at the chat box. Try your best. So it's combination of some quadratic functions, some domain situations, also the inequality. Yeah, morning. If you finish, raise your hand. Maybe I'll give you like 5 to 6 minutes. Because we already try find domain only, right? And then find the root only, how to factorize, right? And then find the solution for inequality. But now it's kind of mixed in a rational function. Remember that because it is a rational function, you have like the top and the bottom. When you deal with the rational functions, the bottom part needs to be taken care of, right? I mean, you should have some set of domain that you need to apply to, right? For example, here, 2x plus 5. You need to make sure that it will stay there. Because when you change the form, if it is not mathematically correct, you will broken the domain. So let me see. Online students. Okay, nice. Nice. Okay. Um, for online students, because I don't know how you are doing it, so I will just pick the first one that answering the questions. I'm sorry. I'm really sorry. Okay, but that's still fine if you want to have exercise. But is it correct? Negative. Oh, I think it's correct. Yeah, I think it's correct. Okay, how about number two? Okay, number two. Okay. Okay. I think number two. Uh, how can I call you Tap or Nguyen? I think you are also correct. Okay. Okay. Who finished? Finish. Finish. Let me check. Hmm. This is number one. Okay. Mm-hmm. So this is this part, right? This part, and mhm. Okay. Can you finish the first one? Let me check. The number is correct, but it's wrong. The number is correct, but you got wrong conclusion. Okay. So which one is your answer? I'm not correct. Not correct. Yeah. You finish? Number one, finish. This one? Not really correct. Not really correct. Mm-hmm. Okay. This one, number one? Okay. Okay. How about number one? You finish? This one? Okay. Okay, let me try to okay. Let me guide you to the solutions. Okay, this is for number one. Okay. Okay, I noticed some of you have 2x plus 5 in the bottom, right? And then you go multiply with 1. Uh, in mathematics, you cannot do that. Inequality. Okay. Because of what? When you do that, you will broken the domain. Okay. This is still your functions, right? The whole function. And 2x plus 5 should be not equaling 0. That's the first thing. So the safest way to solve this is you need to keep this at the bottom. Okay. And you move this 1, go here, so minus 1. Okay. So 2x plus 5, 2x plus 5. And then you just calculate in this top one here. And you will get this negative x, negative 8. And because it's negative, I prefer that the top one to be all positive. So I will multiply all by negative, and it will change the, the sign here. Okay. So from here, I will check. So the idea of all inequality, okay, what I suggest, like since before in the previous week, okay, so you have the rational functions, okay, you have each one, like for the top one, you have the solution, right? It's negative 8, right? For the bottom, it's negative 5/2, right? Do not make any conclusion from here, but make the line number. It's the safest way, because you will be vulnerable having a mistake in this sign, less and greater. You will make making a mistake, I guarantee. So negative 8 put here, okay, and then negative 5/2, 5/2, or it's not 2/5, it's 5/2, right? Wait, I'll make some mistake here. Yeah. So put here, try some value, okay? maybe -9 here, and then maybe negative -3 or -4. You can select and maybe 0 here. Plug in all the numbers. You will get the conclusion: positive, negative, positive. And then also remember, okay, the questions having less and equal. For the top one, it doesn't matter, right? So you can have a full circle or a closed interval, right? But for here, it will be a hole. Why? Because the domain. You don't want the domain to be equal 0. That's why I need to put hole here. So the correct answer will be from -8 less equal x less -5/2. Or you can write close interval -8, -5/2, open interval. Okay. So in this type of questions, it's like a combination of first is it's the rational function. Inside the rational function, you need to consider this bottom one, the domain. Okay. And you also combine with the inequality. Okay. That's the first question. Hmm? Yeah, which one? Mm-hmm. Yeah. Mm. Yeah. Mm-hmm. 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 But the problem in your equations here is if you have 1 here, which means uh, it's not complete yet because you don't really know the exact solution. But so for my suggestion is treat the make the inequality like your normal equations. Your normal equation, for example, if you have x plus 8 is 0, x is -8, right? So you are treat this the equation equaling 0, like this 1. How to make 1 0? You minus 1, right? Make 0. So this -1 here. So you treat the equations like you treat the normal equation by equaling 0. Okay. You can write in your notes like make this like equal. That's fine. That's fine to make your calculation easier. Okay. But later in the bottom part, you need to try the sign. Try to assign number from the interval. You can assign from here, 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 and make sure you get the symbols: positive, negative, positive, and then to make sure that which interval you take a look your equations. So this part, I've changed the symbols here, right? Because I multiply with the negative. So I need to find the less than 0. So I need to find the negative parts. Okay. That's the thing, the safest and logically in math correct and makes sense, and you get the answer. Actually, if you are really familiar with the equations and you don't need the line number, that's fine. But mostly what I saw the students, they tend to be making mistakes here, these signs. And when they make a conclusion, they make the wrong conclusion. Okay. So the line number will help you to define which interval you will take. It is the safest way. Okay. Because I did also when I was still students, I do make mistake here also and make the wrong conclusion. And then when I draw the line number, it's like ensure that okay, my answer is correct. Unless you make the mistake here when you plug in the number. Also, you can make mistake. You can make mistake like for example, you plug in -9 but you get the wrong conclusion from when you plug in the -9. Maybe you got negative here, and then you say, oh, so my answer is here, and maybe you will making that mistake also. So be careful, okay? Be careful when you plug in. Also be careful. Yeah, I think that's it uh, to prevent any to minimal the damage, the mistake. Uh, Online students, do you have answer? Yeah, -5/2. -5/2. Yeah, I wrote the wrong number. Okay. Uh, the next question is this one, right? Okay, so how to deal with this type of, you have quadratic functions there, you have quadratic function here, right? So you can have two equations and you can work with that two equation first, okay? So you don't need to make in one equation like rational function like this, okay? First solve the top one first. Solve, just make like any normal quadratic equation just to find this number first. That's the idea. Finding this number. You don't really need to much care about the sign when you calculate in your um, calculations. Okay, and then try the bottom equations. Try some trial and error. Make the table and make sure when you are multiplying this part and this part, and you adding both of them, it will be making -7. And when you multiply 2 and -3, it's -6. Okay, and you get the conclusion 3x plus 2 and x minus 3. Okay, you just treat them as a normal quadratic functions. You get the number -2/3 and x equal 3. Okay, and then you get your line number. You get your line number here. Okay, and put all your results. Okay, put all your results here. I do take some notes here that x is not equaling -2/3, x not equaling 3 because of the domain, but because it is not equaling 0, so I don't need to uh, take care much of the domain because it's not equaling 0, right? So again, plug in numbers here, plug in numbers in between here, plug in here, plug in here, plug in here. Okay. And one thing for the fractions like this one, be careful, okay? Be careful. Because if you have, for example, in this case, this 1 or maybe this 3, if this also fraction, maybe a over b, you need to find a fractions in between. How you make sure that this fraction is bigger in number? How to make sure that? Here, if this is -2/3, if you have a over b, then my elementary teachers, she taught me, you multiply this, make sure this results, make sure 3a is less than -2b. It's just elementary school trick. Remember? I think you get this from the early mathematics, right? Okay. That is if your number here if it is fractions. Okay, so you do need to be careful. So this is the answer: less than -3, -2/3, and 1 in between. Okay? And x is greater than 3, because the question is greater than 0 directly. Okay, so this type of questions at least will be your typical quiz. Okay, so this is what I expect for all of you to be able to achieve this level. Okay, because actually it's all from the math that you already learned before. It's just like combining some of parts of some domain, some inequality, some quadratic functions. I think each one of the terms you already know, you already learn, but to combine all and utilize what you know, tools you need, right? It acquires um, some level of understanding and some habits. I talked before I think in the Friday class, in the introduction class, but I think it's not everybody. So I thought that you see, some saying practice makes perfect, right? But it will be perfect if you did the right practice. If you did the wrong one, then it will be bad. So practice is actually makes habit. Okay, if you do the wrong way of understanding some concept, then you will be at the end of the day when you are trying to finishing exam or maybe some assignment, you will be doing in a wrong direction. Okay, so what I'm saying is you get the right concept, make it a habit, and that will be perfect. Okay, practice not always makes perfect. So you try to like exercise, but you yourself doesn't really understand the concept, and that kind of makes maybe some of students might think, don't worry, the exam is still maybe a few weeks later or maybe a few months later, and when you are dealing with the deadline, you still not be able to achieve the level. So it will be like it's too late. Okay. Okay. Maybe any questions first from the online students? Do you have any questions? I think clear. I do have some other exercise, but I will keep that for next week. Okay. And let's return to our lecture. So this is last part, okay, before we dig into some exercise. Okay, I will continue to some polynomial divisions. Let me write maybe here, or maybe in the new page it's maybe clear, more clear. Dividing okay, if let's say the polynomial px and let's say bx, okay, both of these are polynomials. Okay, so you have two polynomials, okay, and dx should not be 0. Exists a polynomial qx, let's say qx and Rx. Why the name is QR? I will explain later. Rx is either 0 or a degree less than dx. Probably a little bit confusing, but what does it mean is if you have px and then you divide by dx, okay, it will be qx plus rx over dx. So what does it mean is if you have any polynomial p and d and you divide p by d, okay, you have the result q plus r over d. Okay. So this r, it can be 0 or it can be a degree less than the dx. That theorem. Okay. You can also write this theorem. Let me write. You can also write the theorem px, multiply all by dx, so dx qx plus rx. Same thing. We call the px is dividend. Oh no, with d. This is divisor, quotient, and remainder. I think you just need to remember the r, the remainder. I think most of the questions it will be telling you the remainder. Okay? But as long as you know how and know the form, should be fine. Okay, you don't need to memorize all of this. This is just the definition. The definition is not to be memorized. It's to be understood. Okay, it's different. Okay, for example, I divide 6x squared minus 26x. I just use some examples here. Plus 12 by x minus 4. Okay, this is called this one. We call this is long division. The method, the first method. Okay. So how you divide the polynomial? The first polynomial, this is px. This is dx. So you can write this is as plus 12. Okay. You can try to write the answer, but I will explain the method. Okay. So the method is just like I think elementary division. So you write all the polynomials, the px, p5, right? X minus 4. Let me move this. Okay. So let's just do the division. So this is x minus 4, x minus 4, and the first thing is you see the 6x squared, right? 6x squared, you need to multiply x minus 4 with something, right? So 6x squared, I think you need to multiply 6 minus 4 by multiply by 6x, right? So you write 6x and multiply and write down 6x squared minus 24x, right? And then divide. Subtract. This cancel, right? And this is becoming negative 2x, right? And plus 12, okay? And then the next part is this negative 2x, okay? You need to multiply something to x minus 4. I think it's just multiply by negative 2 to become negative 2x, right? Negative 2, negative 4 plus 8, right? And then minus, it will be canceling, okay? 12 minus 8 is 4. So what will happen next? Just stop here. Okay? You cannot rewrite or change any form, right? So this is the remainder, the Rx. Remember what the Rx theorem before. Okay? Rx, it might be 0 or 1 degree less. Okay, you see the degree is x minus 4. It's only 1 degree, right? Only linear. X minus 4 is linear. The degree below that is just a constant. Okay, so this is a constant 4. Okay, so you may write this as 6x minus 2 plus 4 over x minus 4. Okay, this is high school, right? Do you get it in high school or no? No? Do you get it in high school? No? Why? Anyone got in high school? Got high school? Got high school. Right? High school? Got right? Okay. Okay. Then it should be x, right? To be x cubed. So the remainder will be 1 less degree than the diffeser. Okay. So if your diffeser is squared, then it should be linear, right? Only 1. Okay. Well, let's try a different example, and maybe I will go for also a different method. Okay. So this is the first method. It's called the long division. Why called long division? Because when you have like really long polynomials, you will get like longer divisions. Like so, that's why we call the long division. The next one supposedly to be shorter, but I prefer. I'm not really prefer in both. I can sometimes I'm using long, sometimes the new method here. So for example, you have the 2x, let's say cube. Divide by, let's just make it x minus 3. Well, let's try the long division first, and then another one will be the new method. Okay. So try by long division. So x minus 3 need to multiply by, because it's x cubed, I need to use 2x squared. Okay, 2x squared, 2x cubed. Oh, let me write it red. And then 2x squared multiplied by negative 3 will be 6x squared. Okay, let me zoom in. Okay. This will be cancel. Will be negative x squared plus 5. Negative x squared, I need to multiply with negative x, right? So it will be negative x squared plus 3x, and then minus. Okay. Remember, whenever you find, you have 3x right here at the bottom here, but you don't have any x at here, right? So you treat at the top here because there's no x, so treat as 0, 0x. So okay, so 0 minus 3x, okay, it will be minus 3x plus 5, okay, and then multiply by negative 3 here will be negative 3x plus 9, right? And then minus, it's cancel here, it will be negative 4. Okay, so the remainder is negative 4. This is the Rx. So I can write this as 2x squared minus x minus 3 minus 4 or if you want you want to remove the rational, you can also write the 2x cubed let me move down. The same thing, but this is different from. Okay. I will give you the the next method. Okay. So this is with long divisions. With the same example here, I will go with, it's called the synthetic division. Okay. So how will you do the synthetic divisions? First, okay, first you write in order of the degree. Okay. So first you see here, the degree you are having is cube here, squared, there is no x, right? So x is 0 and then 5. So you write first is 2, okay, negative 7, and no x, right? So you write 0 and then 5. So you have 4 numbers. Okay. Divide by x minus 3. Okay. X minus 3, if you equaling 0, the solution is x equal 3. Okay. So let's just write 3 here. Okay. And here's how you are doing synthetic division. So first, the left part, the number 2, you put number 2 down here. Okay. You multiply 2 with 3 right here, 6, and then plus, becoming negative 1. Okay. Negative 1 multiplied by 3. Okay. It will be negative 3 right here. Okay. Plus, okay, plus with negative 3. Okay. Negative 3 and 3 become negative 9. Okay. And then plus. So you will have, this is 2. So this part will be the remainder. This part will be the 2x squared minus x minus 3. Okay. Any method you are using, a synthetic or long division, I don't care much as long as it's correct. It's fine. Okay, as long as it's correct. If you find this is more easier to approach, then use this way. It's okay. I think there's some weaknesses in this synthetic division, but I will maybe discuss that later. But at least you have two methods now. In some cases, in the exercise, you will see some questions is asking really specific. By using synthetic division, try to blah, 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 blah. But in my case, in any quizzes, I will just give you the questions and do whatever you want. As long as it's makes sense, mathematically correct, it's fine. Okay, so two methods. I will give you one more example and see if you can solve it. You can do with the long or synthetic. Okay. Okay, the questions is 2x cubed plus 5x squared minus 6x plus 9. Divide by x minus 3. So you can use synthetic one, you can use the long division. If you finish, raise your hand. Online students, you can also try. If you find the answer, you can just type in. Anyone finish? Raise your hand if you finish. We'll give you maybe. Uh, okay. 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 I see your answer. Okay. Okay. Good. Good. Okay. 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 Mm-hmm. Mm-hmm. Can you solve? Mm-hmm. Mm-hmm. And what is the answer? Okay. You finish? Okay. is 0? Okay. What do you mean? Wait. How this come from?
I mean, I added this because when you multiply this times this, it gives an x and not an x squared. Oh,
You need to do it one by one. Do not use like whole thing there. You figure one number, one number, one number.
it's like
Square. Yeah. It should be cube. You got it?
I'm trying to put this.
Yeah, I think this is also this number. I think it's correct. It's correct. Yeah, but you can also try to make sure. But I think your answer correct. Okay, good. Okay, so your fail, Judy. Okay, what is your answer? 2x squared, 11x. Okay, so the remainder is 90, right? Okay. Who's the same answer? The remainder is 90. You okay? Correct. Okay. Nietzsche also correct. Let me see. Here, right? Okay, good. Okay. Okay. So, 2, 5, -6, 9, 3, 2, 6, 11, 33, 27, 31. Okay, fast, right? Few seconds. So if you want to try your own way, it's up to you. But this way, less than 10 seconds. This remainder. This is 2x squared. Okay, fast, right? I did it just seeing the number and just multiply, add. Okay. Maybe one or two more session and then we can finish the class. I think we can finish before 12, maybe 11:50, maybe we can finish. Okay, remainder theorem. It's called remainder theorem, but it has some words, but let's just see the theorem first. Okay, so if px divided by a factor, let's say x minus c, okay, then the remainder is, let me see, is the value of, okay, okay, do you get the idea of this word means. Okay, so if you have polynomials, divide by x minus c. Okay, and you get some quotients, you get some remainder over d, right? So when you get the remainder, any number in that remainder, when you plug in those remainders, uh, when you plug in the c, okay, in the uh, from x minus c to the polynomials, it will be the value of remainder. So let me write the px, okay, is equal, let's just say x minus c qx plus r, the form. Okay, so you see when you plug in c, it's c minus c. This whole part becomes 0, right? So of course this is makes sense and logical, and this is become 0. So the value of this p of c will be the remainder. Okay. This theorem, it may sounds like simple, right? But it's actually have some um, usage, especially if you want to prove some roots with really high degree polynomials like x100, x maybe 1000, and so forth and so on. If you can guess at least one of the root, and if you plug in root, it should be 0, right? And this theorem, it can help you to solve the questions if you have like really high degree of polynomials. I'll give you the example. Just an easy example first. So this is a remainder theorem. Okay. I will remind you that every word in math theorem, do not memorize it. It sounds like a bad teacher. Right? Don't memorize it. But there's difference between memorizing and understand the concept. Okay? I hope you understand. Okay. Um, you don't need to be exactly precise, like you need to follow words by words. No. In math, you have also the notations, right? As long as you understand the notations and what does it mean, okay? When you put in the graphs, maybe when you put into some situations, if you understand, then that's it. Math only need that understanding. Okay? So never approach mathematics with memorizing. If you have px is equal 3x 5, okay, you have px, and then what ask quotient and remainder when px divided by x plus 2. And this is the first one. The second one is use remainder theorem to find, I think that's just plug in the negative 2. But you see, uh, when you plug in negative 2, because it's making 0, So it is better if we find the whole p defined by x plus 2, find our own remainder, and that's the remainder will be the same as this value. Okay. Okay. 3, 5, negative 4, 0, 7, 3. And this should be negative 2. Always start with the left part, negative 3, negative 6, negative 1, 2, 4, 4, negative 8, negative 1, 2, 5. Okay, finish, right? And this 5. So x squared, x cubed, x fourth. So 3x fourth. This is the quotient, and the remainder will be 5. So p with negative 2 plug in will be 5. You may notice what is the weakness of this synthetic division. Anyone to guessing? Any guess? It's fast, but it has weakness. Anyone? Any thought? Any just guess? Um, Not really, not really. It can be 0. It can be 0. It can be 0 here. Anything else? Hmm. If this is divided by x squared plus 5, can you use the same method? Can you use the same method? No. But if you have x squared minus 4, you can use the same method. Do you know what I mean? Do you know what I mean? The synthetic method, you need to have a precise, exact, only one solution. Okay? If you have x squared plus 5, then you need to use the long division. But if you have the x squared minus 4, you can factorize. X plus 2, x minus 2, you can choose between 2 or negative 2. You can try, but you need to do twice. Plus 2, and negative 2, and then that's your answer. So you divide by the negative 2 first. You get the answer. Divide one more time with 2. Do you get what I mean? So here. Uh, Let me copy this, the same questions. Okay. If your dx is x squared plus 5, you cannot use, so synthetic will be useless. Okay? But if you have dx x squared minus 4, you can have this as x plus 2, x minus 2. Okay. So first you can do the 3, 5, negative 4, 0. First you do the positive 2. Okay. Yeah, crazy number. Is correct? Yeah, I think it's correct. Okay, you got this. Okay, you have the remainder here. Okay, you also to try, but because it's not 0 here, then the synthetic also failing. If it is 0, then you can divide one more time to -2. Okay, or but it will be making the structure of the functions will be a little bit complex. You can try to divide the quotient here with the syntactic division one more time. But you'll have another remainder, right? So this is another. I think just finish here. It's not included here. This is remainder, the new remainder, and this will be the quotient also. So we have two remainder, but that will render the functions to be a little bit complicated. So I'm not suggesting to use the syntactic division also. But if, okay, when you try to divide by 2 or -2, one of them makes 0, then it will be perfect. It will be perfect to take the next step to make a new syntactic division. Okay. But because we have this is remainder and you divide another one, it's also remainder, then I don't think it will be healthy for you. Okay? So you can go to long division. Okay? You can go just directly go to long division. So this is one weakness for the syntactic division. So syntactic division it may be faster, but you need to have exactly linear in this divisor. Okay? So x minus 2, x plus 1, x plus 8. As long as it is linear, then you can do syntactic division. And you can do like faster than the long division. But when you have the squared cube greater than 1, then long division. Okay. Okay, I think we'll stop here. And we still have several theorems regarding the polynomials. Some sections we will continue next week. And since today is the last day for classes this week, right? So enjoy your holiday. Okay. I hope you can have a good time. Arrange some maybe activity if you want. My suggestion is always making a connection with people. Okay. New people. Okay. New friends that will be helpful in the future. Okay. If you have like colleagues like from your country and you want to make blend in another group, that also good idea, and it will also I think it will give you good vibes and positivity. Remember, as yesterday the Professor Chen said that you need to have a balance. Make a balance, study, have fun, exercise, right? And don't forget to have enough sleep. Okay, and do not study one day before exam. Okay, that is not helpful. Okay. Okay, I think we will stop here. Thank you, online student. See you in the next class. Okay. I hope you enjoy your quarantine. Okay, if you are in quarantine now, and if you are still outside, I hope you can safely land it in Taiwan. Okay. Okay, see you again.